Hello and welcome back to my channel. So in the last video we were talking about how to do integration. The methods of doing integration are will be explored more in this video. In life you don't get simple functions like sin x or cos x. Sometimes we get complex functions and we need to integrate them. So this is where we need to use different kinds of integration. So there are three major types of the methods of integration. The first one is integration by substitution. So I'll just write it down. Integration by substitution. And the second one is integration by partial fractions. And the third one is integration by parts. Integration by parts. So in this video we are going to talk about integration by substitution. So to better understand this, let's try to solve a few problems, and in this process we will get to know what is integration by substitution. I have been given a problem which looks something like this. I need to find the integral of this function x squared plus 1. So here I can see that it is composed of a product of two functions, this one being the first function and this one being the second function. So to simplify those type of problems, we need to check for derivatives. Let me explain here. So like if we pick x squared plus 1 and if we differentiate it, I'll get some 2x, right? And we can see that 2x is already in this function, so I can substitute 2x, let's say I can substitute x squared plus 1 and I can put t equals x squared plus 1, right? So this is the substitution. I've substituted t in place of x squared plus 1, and then if I do dt by dx, I'll get 2x, so which implies that dt equals 2x of dx. So again I need to change the independent variable, so I need to change dx as well. I need to write it in terms of dt. So we got dt equals 2x dx. Now substituting everything in the function, we can rewrite the function as integral of sine t times dt, and we know that sine t, the integral of sine t will be minus cos t plus c. Again that means we have cos of x squared plus 1 plus c. So this is how we can simplify a complex problem by just substituting and making it very simple. But in some cases we don't always have the derivative in the function itself, so in those cases we need to find other methods. So in this case we had the derivative of x squared plus 1 in the same function. That's why we were able to simplify it. So let's move on to the second problem. So here we need to find the integral of tan to the power 4 under root x multiplied by secant square under root x by under root x dx. So I need to find the integral of all of this function with respect to x. So now simplifying it step by step, we can do one thing. We can put under root x as t, right? So dt by dx will give me 1 by 2 under root x, right? So once I do that, which implies that dt will be, so I can write dx will be 2 under root x dt, right? So I can put this one in place of dx, and I can put t in place of under root x. So this will simplify this function a little bit. So I'll get tan to the power 4t times secant square t by t dt. So I'll get 2t times dt, and this t and t will get cancelled out, so I'm left with only 2 here. So in integral we keep the constant outside. By that I mean that 2 will come outside. This 2 is a constant, we'll keep it outside, and then we'll integrate the rest of the function, that is tan 4t times secant square t dt. So here it looks similar, right? We know that the derivative of tan x is, right, the derivative is secant square x, right, if we are derivating it with respect to x. So let's do again substitution. Let's put tan t equals u, right? So du by dt will give me secant square t. I can rewrite this one as du equals secant square t dt. So therefore the function will look like this. We have tan t will be u, so we'll have u to the power 4, and then we have secant square t dt already as du, so we just write du, and 2 is outside. So the integral will be 2 of u5 by 5, right, plus c. So back substituting, we get 2 by 5 of tan to the power 5t plus c. So again, in place of t we had under root x. That means, so originally the integral of the function will be tan to the power 5 under root x plus c. So this is the integral of the original function that is given in terms of x. So this was the function. So this was the function in terms of x. We did 2 substitutions and we finally got the answer, the integral in terms of x. So I'll conclude this video here, and I'll be uploading more videos on integration. I hope you like the videos. So thanks for watching.